Find the value of k for which the equation 3x squared minus 6x plus k is equal to 0 has distinct and real roots. Question was asked in the ICSE 2015 examination. So let's just start by writing down our equation first. The equation that we have is 3x squared minus 6x minus 6x plus k equal to 0 plus k equal to 0 is our equation. They have given us the fact that the equation has distinct and real roots, right? Now remember, they've given us the nature of the roots in this question already. If they've told us it's distinct and real, that means the value of the discriminant d should be greater than 0, right? And d is nothing but b squared minus 4ac, right? So that is what we want to do. We want to find the value of b squared. We want to say that the value of b squared minus 4ac is greater than 0, solve that, and hopefully get the value of k, right? So we start by comparing the given equation with the standard form of the quadratic equation, which is ax squared plus bx plus c equal to 0 plus c equal to 0, and from that we get so I'll just not need this anyway. From that we will get that the values of a, b, and c basically. So I can say a is equal to 3, b is equal to minus 6, and c is equal to k, right? A is equal to 3, b is equal to minus 6, and c is equal to k. So I have the values of a, b, and c. Next, what I'll do is I just need to find the values of the I need to find the value of the discriminant. Now, since they've told us the roots are distinct and real, right? So we know one thing, that we have distinct and real roots. Since the roots are distinct and real, what that means is the discriminant d will be greater than 0, right? Real and distinct and real roots, or rather real and unequal roots, is where the condition is for is possible when the value of d is greater than 0. So that means b squared minus 4ac, d is just b squared minus 4ac, this value, right, must be greater than 0. So let's just substitute our values of a, b, and c here and solve the equation. So b squared is minus 6 squared minus 4 into a is 3, and c is our variable that we need to find, which is k, right? And that value is greater than 0 for distinct and real roots. So simplifying this further, minus 6 squared is 36, 4 into 3 is 12k, greater than 0. Rearranging the terms here, I get I get that 12k is, if I am to rearrange this, I take the minus 12k to the other side. The equation I have 36 is greater than 12k. Dividing both the sides by 12, I get 36 upon 12, which is 3. So, right, and 12 upon 12 is 1. So 3 is greater than k, or I can say therefore the values of k, the range of values of k for which our given equation has distinct and real roots is k less than 3. This is my final answer.